Hi, welcome to today's video. Today we are going to start a new series of video, that is linear algebra. Before that, I need to give you a brief introduction about what is linear algebra and why it's important. See, talking about linear algebra, I just want to give you some examples. Working of a Google map, 3D animations in the movies, we can see animation movies, artificial intelligence, how it's work. These all are powered by linear algebra, the principle called linear algebra in the mathematics. Linear algebra is the math of straight lines. Straight lines means whatever is in the straight path, flat surfaces, space of any dimension. It is used special tool called vectors and matrices to describe relationship between straight lines, planes, and any other dimensions. See, like how things move, connect, change, all this relationship we can work it on with linear algebra. So before that, why it's important? See, everyone will think why linear algebra is important. See, as I discussed, the major fields where it is using, like Google Map and intelligence and 3D animation. See, these are the major field. These are not the major field. There are a lot of other fields also there. So before that, why it's important? In video games, science. See, in science, it's very important, right? Because if you try to model something, for example, linear algebra helps to model the motion of a planet, the planets, right, in the space, the motion of planets, motion of the objects, everything is tracked down and modeled using linear algebra. In data science, linear algebra helps to find patterns in the massive amount of data. Even bulk, huge or big data is raw data is coming in front of us, find the patterns in from the big data, I mean raw data. This linear algebra plays an important role. Even the smartphone, right, even the smartphone face recognition, pattern recognition, see, fingerprint recognition, everything is powered by this linear algebra. Before that, we going into the deeper concepts of linear algebra, we need to start from the basics. Okay, before going for the vectors, planes, matrices, this is some deeper level. So before that, we need to start with linear equations. We need to start what is linear equation. That's a basic foundation of the linear algebra. Okay, linear equations are the building blocks of a linear algebra. Okay, so we will crack down step by step. So let's move to the linear equations. Okay, let's see the definition and concept of linear equation. What is, as the statement says, a linear equation is an equation where the highest power of the variable is 1. Look at the example of this linear equations. So in this linear equation, another informal definition is it's a sum of numbers. We call a sum of numbers multiplied by its variables, and it will be equal to a number. So here, this is coefficient. This is called coefficient. Coefficient means then a number times a variable, the number just before the variable here. So x is x, y, z is called variables we call as variables. So the value of this variable is unknown, but we need to find out, we need to solve the linear equation, means we need to find the values of x, y, and z. But the total sum we know already, this 27, and this coefficient is this one. So 4, 5, 7 are called coefficients. Okay, when this coefficient multiplied by variables, and this is called a term. First term, second term, third term. So the sum of these three terms are already known, 27, but we don't know the value of x, y, and z. Okay, this is how a linear equation look like. So in this part, we can say a linear equation can be two term or one term or any term. For example, there is one variable linear equation. One variable means there is only one variable on that equation. So it's x. Equation we can rewrite like this. So 2x is equal to 7 minus 3. But 7 minus 3, so 2x is equal to 4. Like this also we can 4 by 2 is equal to 2. So x equal to 2. So in a single variable, we can directly we can find the value of x. We can solve the equation very easy. But when we go for this two variable linear equation, like, see here x and y are two variables, and x has a coefficient of 2. This is a coefficient of, and y has a coefficient of 1. So there's 1 here, but no need to mention the 1 here because there is no number mentioned here, that it should be assumed that it's a 1, and the value is 5. So to solve this equation, we need to do some techniques, so that I will explain you later. Keep in mind, a linear equation is an equation where there can be one variable, two variable, three variable, you can do any variable, but the highest power of each variable, any variable inside the equation should be 1. There is no x square. This equation is not a linear equation. Why? Because power is 2. So the power of the x is 2. So it's greater than 1. That means, as per statement say, this is not a linear equation. This is also not a linear equation. Why? Because the product, it should be the sum is equal to 3. Then it should be a linear equation. When we write x, y, then it is not a linear equation, because product of two variable doesn't comes under the linear equation set. You need to keep in mind, the linear equation is an equation that can be written as the sum of numbers, I mean coefficient. Sum of numbers, I mean coefficient, times the variable added up to give an equal to a number. So this is the one. The sum of a number coefficients times variable. So this is a coefficient times variable added up gives a value, that is gives a number. So this kind of equations are called linear equations. Okay, so I hope you have a basic idea about linear equation. So make sure this model is not a linear equation, and this type of equation is also not a linear, because here x squared is come, so not a linear equation. Here product of two variables came, that's why it's not a linear equations. Okay, let's see the standard forms of linear equation. So linear equation has we'll discuss about one variable and two variable. So one variable linear equation has a form of ax plus b is equal to 0. So here how many variables? Only one variable. Okay, see two variables, so ax plus by plus c is equal to 0. So here x and y are the variables, so there's two variables. What is a, b and c? So a comma b comma c, these are numbers, or we can call as coefficients. So here this a and b are the coefficient, but c has no variable here, so it we call as number. And this is the standard form of one variable and two variable. We can go for any variable like a x plus b y plus c z plus d is equal to 0. So we can have 1 2 3. See, basically when we increase the number of variable, each variable represents the dimension. So in real life, imagine that this system of linear equation, each variable represent the dimension. See, one variable represent one dimension, two variable represents two dimension. So basic level we will start with one variable and two variable. Okay, let's go for some examples. See, which of the following are linear equations? So we need to find out which are the linear equations. Just say yes or no, that's it. Okay, so let's guess. Just pause the video and just try to guess it. See, check the first equation. See, 4x square plus 5x plus 6 is equal to 0. So at the first look itself, we will know that it is not a linear equation. Why? Because this term, the variable power is 2. So x square come. So the power should be, the highest power should be 1. So here it comes 2. So it's called, we call this as not a linear equation. Okay. Go to second one. 1 by 3 uv plus 2 by 3 u is equal to 3 by 5 v. Same thing happened here. See, here two variables came together. There is a product. It comes u times v. The variable should not become on this type, because the variable should be on the added up. Variable should be added up and given a value. So this is the two variables come together, product of variables present here. So it is not a linear equation. Then the third one, see, 5a plus 2 is equal to 6b minus root 2c. So in the first place, we'll know that there's a root 2 come. There's no problem. If there's a root 2 come, it's a number, it's a value. So it's a coefficient of c. You can just rewrite this equation like this to see it's very simple. So 5a minus 6b plus root 2c is equal to minus 2. See, this is how we rearrange the linear equation to make the standard form, to look like a standard form. Okay. So here this is a linear equation. See, 5a minus 6b plus root 2c. See, this c is outside and not inside. Root 2c is equal to minus 2. It's a linear equation. So otherwise you can write as 5a minus 6b plus root 2c plus 2 is equal to 0. So both are same. So as per our definition, this is a linear equation. So the first two are not a linear equation because the first one x square came present here. Second one is product of two variables present. So that's why it's not a linear equation. Hoping everybody got an idea about what is linear equation. Okay, so let's wind up here. We'll move to the next topic.